So as we continue to work with linear equations and graphing, let's look at this question here. It starts to move into a table. So this question says, find 5 solutions of the equation. Select integer values for x, starting with -2 and ending with 2. Complete the table of values below. So they've already kind of done this for us. They picked values for x, -2, -1, 0, 1, and 2. Notice how they said integer values. So integer values are positive, negative whole numbers. So we don't have to deal with fractions or decimals because they're not asking us to. So remember, when you're working with two variable equations, the value of x can be any value that we want. So we can substitute any value of x that we want into the problem. And when we find the corresponding y value, those two values create an ordered pair, which represents the solution to the equation. So all they want us to do, though, is find 2 of the solutions, or I'm sorry, 5 of the solutions, starting with -2. So the way this works is, again, in working with equations, they're like functions, if you will. There's like this input-output stuff. So what they're asking us to do is pick this -2, and it has to go through a series of operations. So the x is going to get replaced with a -2. So we're going to be going 12 times -2 minus 9. So if we want, we can do this by hand by following the order of operations. -2 times 12 would be -24. And then if we add a -9 to that, or lose 9, again, I think I see it better as -24 plus -9. So if I combine a loss of 24 with a loss of 9, that means there's a loss of 33. So what kicks out is a -33. So remember, the x kind of represents the input. The input goes through a series of calculations, and the result is what we describe as the output. So again, the x is what's called the independent variable. We get to choose what it is, but the y value is going to depend upon what the x value is. So when -2 went in, -33 came out. So if I pick a -1, so if I want to, I can use my eraser and erase all this and reload my function. Don't have to actually erase it all. So what we're doing is we're actually now replacing x with a -1. So -1 is going into my function. So they want us to perform the calculations and find the value for y. So 12 times -1 is -12. And then again, if we add a -9 to that, so again, to me, that's the same thing as the -12 and a -9. So again, I'm using kind of what we call the circle method here, if you will. So this is a term, and this is a term. That's how I'm kind of seeing it. It just makes it easier for me to do the math mentally when I work with positive and negative numbers. So if I have a loss of 12 and a loss of 9, that seems like that's going to be a loss of 21. So I'm picking up on a loss of 21 there. So -1 went in and the -21 came out. So this represents a solution to the equation. So again, if I can erase all this. So now if I want, I can substitute the 0 into the problem. So 0 is going to replace the x in the problem. So I'll go 12 times 0, which is going to actually be 0. And then you have a -9. So again, I'm starting with 0, and then I have a loss of 9. So to me, again, that's the same thing as 0 plus a -9. That's my thinking. So I'm starting with 0 and I lose 9. So now I'm actually down 9. So -9 would be the result. So when 0 goes in, -9 would be the result to that. So that becomes my solution, that those two numbers together, that ordered pair, that X and Y creates a solution. A lot of times, like I said, they'll write those as ordered pairs. So -2, -33 would be a solution. -1, -21 would be a solution. 0, -9 would be a solution. I don't think they're asking us to actually do that in this problem. I think they're just asking us to complete the table. So if I put 1 into the problem, that would be my next value. Gets a little bit easier. Working with positive numbers now. 12 times 1 is 12, and 12 minus 9, that I really don't, that's just normal math. 12 lose 9, that would just be what? 3? 3 plus 9 is 12, so that makes sense. So my solution there would be 1, 1, 3. So that would be that. So again, if I want to write that as an ordered pair, 1, 3. Because you remember in an ordered pair, the input value or the X value goes first, the output value or the Y value goes second in this, if we're talking linear equations or functions, if you will. So notice how when it's solved for Y, it kind of makes the math go a little bit quicker as well. So if you want, you literally could almost do this mentally if you're pretty good with your math. So 12 times 2 is 24. 24 minus 9. Can you do that mentally? Sounds like 13. 13 plus 9 is 24. No, I'm a little short, aren't I? How about 15? 15 plus 9. That sounds more like it. So 15. So notice how I'm actually using addition. My subtraction. The subtraction kind of stinks sometimes, but if I go backwards, does 15 plus 9 get me back to 24? Yeah. Because again, I can think of 15 plus 9 as 15 plus 5 plus 4. So remember, the 9 can actually be broken apart as a 5 and a 4, and I'm really feeling confident with my answer if I'm not using a calculator. So 2 goes in and 15 came out. So that solution would be 215 as an ordered pair. So again, I think all we're asked to do is just fill in the Y values there on that. So again, check me in my lab and make sure that's all they're wanting us to do. Okay.